Okay, so in these next two videos, what I want to take a look at are anonymous inner classes and lambda expressions. And as I had kind of briefly mentioned at the end of the previous video, I noted that these aren't really things that are truly related to inheritance. Instead, what they're really related to is this just another way to implement our classes or our interfaces. So the primary reason that these are discussed at this moment among the materials for this course is because of the fact that since we just addressed interfaces, this is a good opportunity to address some very concise and very clear ways to go about implementing interfaces. So what we can go ahead and do is create two files for a new project. So if you want to go ahead and make this through an IDE, you can make a project that you'll end up calling calculator. So we're going to go ahead and just create a new Java program. So we're going to go ahead and call it calculator.java. And what I'm going to go ahead and do for this is I'm actually going to make this file an interface. So we're going to do public interface calculator. And inside of here, what I'm going to go ahead and create is just a single abstract method for this interface. So I'm going to say public. For this one, it's going to be, it'll end up being a method that is capable of returning a double. So we'll say public double, and we'll call it calculate. And the purpose of this method, once we actually go about implementing it, is that we want to be able to use it for any kind of binary operation. So that would include things like addition, subtraction, multiplication, or division, possibly even the modulus operator in programming. So I need to go ahead and be able to pass in two parameters for this. And since I'm going to be returning a double, the two things that I pass in should probably also be doubles. So we'll have a double. We can call this our, essentially we could think of this as our first operand. So I'll call it first opt, or just first op. And then the second parameter will be our second operand. So say double second op. And so now that we've got our definition, this header for our abstract method, we can go ahead and create an additional file and go about implementing this method. So go ahead and create another file. We'll save this. I'm going to call this one calculator demo. Calculator demo. So we'll go ahead and create our class header, public class calculator demo. We'll have our main method, so public static void main. And inside of here, what I'm going to go ahead and do is just make a new reference variable for my calculator. So we'll have our calculator, we'll call it calc, and this is going to be equal to, and what I'm going to go ahead and do is make this equal to a new calculator object, but there's a little bit of additional information that I need to provide. So we're going to say new calculator, and we're going to set it up as if we're calling the constructor, but as we already know, calculator is an interface. So if I only leave it at this much right now, this couldn't possibly work because of the fact that calculator has some abstract methods in it, so I can't construct objects from it, at least not in this manner. So what I can do instead is add some additional code to this to, instead of making this just a simple object construction, turn this into what is known as an anonymous inner class. So in addition to my constructor that I have right here, I'm going to add a pair of curly braces. And inside of here, what I need to go ahead and do is effectively implement the different methods that this interface consists of. So I need to provide an implementation for this calculate method inside of here. So right here, we'll go ahead and do our public double calculate. So we need to make sure that the name of the method still matches what we had over in our interface. The one thing that we do at least have a little bit of control over, or a little bit of flexibility with, in addition to the implementation of the method itself, is also going to be the parameters for it. So we can actually change the names of the parameters. So maybe if you want to say something like double first and double second, they don't have to be exactly the same as what they were here. The only thing that has to stay the same is the method signature, and also we need to make sure that the return type stays the same. Okay, so once we set this up, we can go ahead and include some code for our implementation of this method. So let's say for right now we want to do something very simple. Let's just return the sum of first and second. So we'll just do return, and we'll do first plus second. Okay. So at this point now, given the code that we have, we created a reference variable for calculator. We have this call to the constructor for calculator, and then in addition to calling the constructor to make an object of our calculator, we also went ahead and included some additional code to actually provide essentially a class definition, if you want to describe it that way, or effectively an implementation of the abstract components of it. So we're basically doing both the implementation and the object construction all in just a single line of code this way. And the really convenient thing about doing this is the fact that now we don't have to create yet another file just to be able to implement our calculate method. We instead only needed these two, our interface and then our demo file that has our main method inside of it. So now that we've got that, then we can go ahead and use it. So I'm going to go ahead and make a print statement here. So we'll do system.out.println. And inside of this print statement, I want to go ahead and call this calculate method that we just implemented, but I'm going to make sure that I call it specifically on calc, since this implementation, adding the two numbers together, is unique to this particular variable. So we're going to say calc.calculate, and then I'm going to pass in some numbers. So we need to give it two doubles, let's say something like 10 and 5. We'll save that, and then the expectation is that we're going to go through this method, we'll add them together and return that, and with this print statement, we'll print out 15 to the console. So we'll come over here, we'll go ahead and compile that. So we're going to have our two files. I'm just going to use the wildcard to implement both, or to compile both of them at the same time. Go ahead and compile that. We'll then go ahead and run our demo. So we've got our calculator demo, and we get 15 printing to the console. Okay. So another thing that's really convenient about using an anonymous inner class like this is the fact that we can actually make multiple different versions of our calculate method all within this one piece of code. And again, we can avoid having to create multiple additional files to implement this in different ways. So what we can go ahead and do is we can have another calculator. This one we'll go ahead and call calc2. Say this is also equal to a new calculator. Go ahead and have our constructor and then the body so that we can go ahead and implement this. Again, we need to specify our calculate method. And again, we can give our parameters any names we want. Just have to make sure that the method signature as well as the return type are consistent. So for this one, we could say double fir and double sec. And let's say for this one, I want to go ahead and just do the difference between them now. So we can do something like return, keeping the names here consistent with what's in the scope, do fir minus sec. And then coming down here, we can go ahead and print this out as well. So we'll do system.out.println. And now I need to make sure that if I'm going to use this version of my calculate method, where I'm doing subtraction instead of addition, I just have to make sure that I call it using the correct variable. So I've got to make sure that I use calc2, since calc2 is the one where I implemented calculate as doing subtraction. So we'll go ahead and do calc2.calculate. And let's say, again, I want to use the values 10 and 5, so just pass in the same two values. So for this one now, fir is going to be 10, sec is going to be 5, we do 10 minus 5, and that will give us 5. So we'll do these two print statements. The first one, using this method, is going to give us 15. The second one, using this one, is going to give us 5. So we'll compile this. We'll then go ahead and run it, and we can see 15 and 5 right there. And if we wanted to, we could go ahead and keep on doing this. So what I'm going to do now is just grab this little piece of code, copy this down, make this calc3. We'll go ahead and do public double calculate. I suppose we can go ahead and leave the variables the same. And let's say for this one I want to do multiplication. And then maybe for one more, change this to be calc4. And we're going to do division for this one. And then coming over here, in addition to these two print statements that I have right now, again, I can just go ahead and grab one of these. I'll copy that down twice. Change this to a 3, this to a 4. And now what we're going to go ahead and do is the first line is going to call the calculate method using calc. So we're going to do addition there. The next one's going to call calculate using calc2, which is going to do subtraction. The third one's going to call calculate using calc3, which is going to do multiplication. And then the fourth one is going to use calculate on Calc 4, which will do division. So we're going to do 10 plus 5, which gives us 15, 10 minus 5, which gives us 5, 10 times 5, which gives us 50, and then 10 divided by 5, which gives us 2. So we'll go ahead and compile this again, and then we'll run it, and now we can see each one of those 4 values printing to the console. Okay. Okay, so this is going to wrap up everything with anonymous inner classes. Going into the next video, I want to take a look at this same example using these 2 files, but I want to replace these anonymous inner classes with implementations using Lambda expressions instead.